Before showing the demo of the actual plugin, it's better to go through the steps and the sequence of the actions which is going to take place while we are running a federated machine learning scenario. As it's been described in the document, in a federated machine learning, the clients, or let's say the data providers which provide the data, they do not share or transfer the data, locally stored data, to any server or to the data consumer. So the data stays as it is on the clients, and the data consumer, which practically has a model which it needs to be trained on the local data on those clients, share the model with the server, which is acting as a aggregator and orchestrator on top of the clients. And then the server distribute the model variables and parameters to the clients, and then the clients doing the training locally on the data sets, and then depend on the number of rounds which has been requested for the training. On each round, the clients will just send the model updates which has been trained on the local data to the server, and then server aggregate all those model parameters to one global model. Depend on the strategy, we have different strategy, but let's say federated averaging on top of all those models. And then the next round, depending on the number of rounds which are required, will be started again. So the new updated model will be distributed among the clients, and then the clients will will again run the locally training on this new updated model, and then they send back again the parameters. And these steps will be repeated, depends on the number of rounds which are required. At the end, the final model will be aggregated and ready by the server, and then the final model can be transferred to the data consumer. So now let's start the plugin. So as it's been mentioned, also there's a GUI, but the functions also available via API. So first of all, the data consumer should set up the federated machine learning scenario. So it describes how many rounds required, what the strategy needs to be selected for the aggregating, and then how many minimum number of clients to be participating in its training, because the data could be stored, for example, on 5 different clients, and they want to participate on the federated machine learning, but for any reason 1 or 2 clients, for example, cannot participate at that time. So, or it's been required for example, at least 2 clients should be sending their updated model, and then the IPs of the clients will be added on the ports, because the clients should be communicating with the server. So this needs to be required, and if there is any firewall or limitation in place, this should be configured so that they could be able to communicate with the server. Once it's been set up, then we need to run the federated. We can run the federated machine learning. So first of all, it's the consumer. In this step, the data consumer, which intends to train its own model locally on the client's data sets, need to upload the initial model and upload it to the server so it can be trained locally on the client's data. Once it's been uploaded, then the data consumer select the setup which has been set up in the previous step, and then start the training. So this will initiate the training on the server side. The clients should be available, and they have to have the client's application also ready and running on their sites, because this is a bit of collaboration between the clients and the server. So they need to be in contact, and this should be running on the clients. As you see from the logs also, you can see that the clients and the server start communicating, and the clients receive the initial model and start fitting and trained locally on their own data set. This will, as I mentioned in the sequence diagram, this will be repeated based on the number of requested rounds. For example, in this setup, we have 3 rounds. This will be happening, and then each round a new training will happen locally on the data sets. On each round, we can also see if it's an unsecure, unencrypted way of training, because the other one which takes a bit of lengthy time. So we see that each round will send the bias, the value, and the updated model for each round printed on the server side. At the end, we can see the final model that can be uploaded to the data consumer. At the end, as you can see, the model has been, the training has been finished, and the final model is now stored, so it can be transferred to the data consumer through the data marketplace, any marketplace which using this plugin through its means. Thank you.